This is the World Robotics Championships. Thousands of students from around the globe have poured months of their lives into designing, building, and programming these incredible robots.
We're off in qualification 87.
If you want to see the intensity, the mind-blowing innovations, and the roller coaster of emotions that define a world-class robotics event, then you're in the right place. I'm Coach Pratt.
1, 2, 3, Dutchman.
And with over a decade as a robotics educator and having coached FTC teams to national championships and Inspire Awards, I've lived this. In this video, I'm taking through our teams.
The team from the Netherlands, Team 23014, the Flying Dutchman.
Entire journey at the First Tech Challenge World Championships for the FTC 2024 Into the Deep season. So what exactly is the First Tech Challenge or FTC that has thousands of students so fired up? So it's a global sports league, but instead of balls and nets, it's robots and complex game fields. High school teams, like ours from the Netherlands, get a brand new game each year. Then they get about 12 intense weeks to brainstorm, design, build, and program a robot from the ground up to tackle that challenge. The game is played in partnerships with another team, so working together is a pretty big part. But first is more than just winning. It's about developing crucial STEM skills, problem solving on the fly, learning from industry professionals, and even something called gracious professionalism, which means competing hard, but also helping out your competitors. It's an incredible program that builds future engineers and innovators. These games get complex fast, so I'll break down this year's challenges quick. The game is played on a 3x3 meter field with 2 alliances, with 2 robots on each red and blue alliance respectively. Robots had to go into the center structure to collect plastic rectangular prisms and place them in the respective baskets on the corners of the field for 8 points. Or they could bring a sample to a human. This human adds a special clip to the plastic piece, and then that allows the robot to hang this piece from the center bar for 10 points. In the last stages of the match, the end game, robots can hang from the bottom rung for 15 points, or grab the bottom bar, lift themselves up off the ground, and then grab the top bar and lift themselves up for 30 points. There are more complexities to the game, but that's a rough idea. We started the journey to Worlds in our home of the Netherlands. Bringing all the parts you need for competition isn't easy, and we loaded everything up into a bunch of different suitcases. And while I thought that most of the tools had made it into their checked luggage, somehow a hand drill had made it into carry-on. And surprisingly, bringing this to security wasn't actually a problem. This year, the World Championships is at Houston, and we spent the first day traveling out to our hotel. With day 1 done, day 2 kicks off at the NASA Space Center.
How are we feeling?
Pretty good, hyped, tired, but excited for Worlds.
We had some extra time before the competition started, and with so many of our parents working for the European Space Agency, it was a no-brainer to take a look. Standing beneath a Falcon rocket at NASA, it's impossible not to feel the weight of that possibility. And after NASA, we headed up over to set up our pit. Your pit is a place to showcase your robot to other teams and to hang out between matches. The cool thing about FTC is it isn't just about robots. It's about building a STEM community and building your skills as an engineer.
We're here in the George R. Brown Convention Center, coming to you from Houston.
We just set up some banners we had created to showcase our learning journey this year. As we're coming in from overseas, we had ordered a lot of things for our hotel to build a separate pit. And sure, our tent may be missing a roof, thanks Amazon, but it actually made our pit a lot brighter compared to what other teams had, so we rolled with it. Also, the new roof didn't arrive until after the competition, so we didn't really have much of a choice anyways. In the evening, we reconnected with an old team from Lithuania, Litva. During our regional qualify meet, we invited them to our school for the week to see how we did robotics, and we ended up winning the tournament together as partners. And it was a great time to be able to reconnect and a reminder for our students that robotics doesn't just solve problems, it also is helping build bridges between people. With a few days of rest to shake off the jet lag, competition of day one was intense. This day is the judging day. It's all about showing off what you've learned. Teams get 5 minutes to share their learning, then they get grilled for 10 minutes with a question about the robot and their learning. It's even harder at World Championships because you've got another team standing right beside you with a sheer curtain separating you and the other team who's talking about their journey. Man, talk about distracting. After judging, a robot gets inspected to ensure we're field legal, won't tear up the field. And thankfully, we mostly smoothly passed. We only have one official match day out of 10 matches total over 3 days, so scouting becomes our secret weapon. Our team heads off and starts interviewing and scoping out other teams in the division. This year, there were 256 teams competing, and we were competing against 64 other teams in the Franklin division. While some of our members are out scouting, the drive team is out on the practice field testing our robot. And this is really where our problems begin to start. Before this competition, we'd made our robot out of acetyl or Dutchman, a special kind of plastic. Last minute, we decided to change our side plates out for aluminum, and while it may look a lot cooler, it may have been a bad idea. Yes, it made our robot much more rigid and much more solid, but this extra rigidity ended up causing our robot to break in unexpected ways. So during our practice matches, something broke every single test. A claw, an arm, a joint, whatever. We were fixing something every time. But this is the engineering cycle in practice. Find a problem and make a solution and move on. But then a new problem would arise. And by the time the first match, we'd put on our last replacement arm, hoping that this would hold for the match for the tournament.
From the Netherlands, team 23014, the Flying Dutchman.
We held our breaths while we were watching from the stands, only for our robot to fail with that joint. And naturally, we lost the first match. But thankfully, the story doesn't end there. One of the core tenets of FTC is gracious professionalism. When our robot faltered, the spirit of gracious professionalism shone brightly in the community. Competitors turned allies stepped in to help, proving that this community we're all in together. To fix this arm, we had to redesign it, but we didn't have a 3D printer to make a new part. But with over 200 teams there, we reached out on Discord, and over 20 teams said that they'd be happy to print off our part for us. And this was our competition helping us. And honestly, as a teacher, it's really inspiring to see these groups of students come together. And it was a moment that made me feel really proud to be part of this community. So we sent this part off to one of those teams to help print it off and hope that we'd be able to find out tomorrow to get it installed quickly. So while our first match threw us a curveball with a broken arm and a lost match,
Perhaps not the day that we were hoping for, but maybe the day that we were expecting.
rather than letting us get this down, it really just fired up our determination.
The next day has always been better.
We learn, adapt, and get ready for the next round of engineering tomorrow. But little did we know that there were a lot more bumps coming down the line on day 2. Day 2 of the competition started with much more hope.
Starting off day 2, and our mount for the outtake claw broke, shattered completely because of some forces on the axle. So hopefully that goes well. We're replacing it right now. It should be ready by the first match.
During our national championships in the Netherlands, we had also started off rocky, so we thought we'd be able to pull this one back. Mission number 1 was to install a new arm piece. And it slotted in perfectly. It's a huge relief and a testament to quick thinking and community support. But the fix wasn't that simple. It seems like you got a problem. So placing that arm meant we had to completely restring our linear slides, a string mechanism that lifts our main arm up and down. So note to ourselves, modular design next season. This integrated setup cost us some precious time because we had to completely disassemble these slides anytime we wanted to change or fix a part. With the robot reassembled, we headed into the qualifier match 2. Hopes were high. Maybe yesterday was just bad luck?
T-minus 3, 2, 1, go!
Okay, take a look at this. The robot moves forward in autonomous, and it stops short. The touch sensor on the front didn't hit enough of the wall squarely enough to be able to trigger. What seems like a tiny alignment issue actually has some huge consequences in that autonomous period.
Let's see those fours.
Back in the pit, team diagnosed it fast. The solution? Some ingenuity under pressure. This little flat made from a screw box lid increased the surface area. Simple, effective, and made from some scrap parts. That's the engineering spirit. But day 2 quickly taught us you fix one problem and another one might be waiting.
How are you feeling at this point? I think I'm more excited than yesterday.
It became a relentless cycle and a true test of our engineering resilience. Heading into qualifier match 3, we felt slightly more prepared.
The Flying Dutchman.
Our autonomous period starts.
3, 2, 1, go!
We place the first specimen. And that one flies off, landing right between us and the wall. So now, as you see, the robot can't get close enough for even that modified touch sensor to work. And if you look at the outtake during these driver controls, see that arm slop? One of those gears inside that outtake claw was slipping, and we couldn't reliably score for the rest of the match. Between these matches, it's all hands on deck. You had to take the whole outtake apart, identify that slipping gear, and then try to reinforce it. It's amazing what some zap straps and cable ties can do. On qualifier match 4, we adjust the speeds, hoping to avoid those sensor issues. This time, we're going way too fast. See how it hits that wall and then bounces back? We realize that the competition walls here are way more rigid than the practice field. That bounce through the whole auto off and then snap. This time, the gear didn't just slip, it completely broke. And that's game over for scoring through the rest of the match. 4 matches in, and the constant setbacks were starting to take a toll. You could really feel the morale dip. Our scouting team, who's usually buzzing and gathering crucial data on every other robot, which is vital for strategy, especially when your robot is struggling, they really started to lose some steam.
And how are you personally feeling?
Anyway, I mean, I think sleep is important, and we got lots of sleep last night. So yeah.
Okay.
And it's really tough to stay focused on gathering alliance data when your own machine keeps breaking. And it really pained me to see this, as scouting is one of our team's biggest strengths. And we really could have used this valuable data to help inform some other teams and repay that gracious professionalism they'd shown us earlier. Seeing the team flagging, we knew we needed a bit of a mental reset. Sometimes you have to step away from the fire to regain that perspective. So we took a walk, checked out some of the insane FRC robots, and saw some of the younger first LEGO League kids. Good reminder of the bigger picture, the shared passion for building cool things, and that we weren't alone in facing these challenges. And amidst the chaos, there were sparks of brilliance and recognition. We got this awesome compliment from the head referee. He loved the first logo we had integrated into our robot side and said that he'd never seen anything quite like that. It was a really small thing, but it really meant a lot to our team. And the students, they pulled off something super innovative, using a laptop during the match. So normally you aren't allowed communication devices up in the match pits. But because the device has no Wi-Fi and no Bluetooth, it's totally legal. And our student drive coach made his own program to track their scoring cycle times in real time against their averages and inform the drivers when it was time to start scoring. Some of those smart tactics to optimize scoring, even when we're fighting with mechanical issues. But the robot gremlins weren't done with us quite yet. Qualifier match 5 saw another break. And this time, the casing around the claw mechanism fractured. Time for more pit repairs. And then came the final match for the day, qualification 6.
T-minus 3, 2, 1, go!
Take a look at this autonomous. Totally haywire. Spinning, hitting a submersible. We think it might have been some corrupted code that flashed right before the match. And teleop was also rough. There was heavy defense being played against us. And then our outtake broke again. But our alliance partner's intake broke. So some quick thinking. Our drivers started feeding them the pieces so that they could still score. So amazing teamwork. Then in the final few seconds, we go for the hang and... I don't know if you can see that, but a string breaks, so we need another repair.
I gotta say, that's pretty impressive.
The whole bearing came out when we hung.
Whoa!
So day 2 was absolutely relentless. Broken claws, sensors, gears, casing, string, code glitches, a constant barrage.
Obviously, a couple of tough losses today.
And each fix was met with a new failure. That arm part to Prince overnight, though, it held strong, and that was a nice victory. But everything else seemed determined to test our limits.
How are we feeling?
Mid, because I feel like we did make a lot of improvements.
I think just asking more questions to the teams, more about their team history, more about the challenges that they've faced along the season.
We're battered, tired, and facing another early morning of repairs tomorrow for the final qualification matches. But something shifted today.
You know, it's still Worlds, so like it's pretty awesome that we're here anyways.
How was our performance, would you say?
We were gradually getting better.
You want to make some of those next year?
I think so, you should.
The students proved that they could handle anything that was thrown at them. They learned how to fail, fix, fight back over and over. And sometimes that relentless cycle finally leads to a breakthrough. And we have one more shot tomorrow to put it all together. And hopefully all these hard-learned lessons finally pay off for that one killer final match. It's the dawn of the final day of qualification matches. And honestly, after the absolute roller coaster the last 48 hours we've had, just being here this morning feels like we've really finally ironed out those kinks and have a fighting chance. Started the day near the bottom rankings, but you know what? The kids were actually in better spirits. I think they come to terms with the first rough couple of days, and were just determined to make the most of the final qualification day, to leave everything out on those fields. The first order of business was restring those linear slides. This meant another careful, time-consuming repair before we could even think about the first match of the day. Then comes around to match 7, our first match, and the team pulled off something I've honestly never seen anywhere in FTC, a mid-match human player switch. So in FTC, teams play in alliances, and each alliance has one human player who interacts with the game from outside the field, like feeding in game pieces to the robot. We really wanted to run our specific autonomous routine, which our human player knew inside and out. But our alliance partners for the match wanted their human player for their driver-controlled period because they were more familiar with their robot's needs during that time. So, our human player started the match, ran our auto sequence. Then, as soon as that autonomous ended and the driver-controlled period began, they did a quick badge swap with our alliance's human player. So our human player then became our partner's drive coach from the sidelines, and their human player stepped in to feed pieces to our lines. It was a fantastic bit of quick thinking, communication, and collaboration. So technically, I coached 2 teams at Worlds. Now, we still lost the match on points, but that clever maneuver, a bit of shared strategy, and some fun did wonders for the team morale. It honestly made up for a lot of those built-up frustrations from the previous days. And throughout the day, that collaborative spirit continued to shine. Our scouting team, even though our robot wasn't performing at its peak, was actively going around and sharing the data that we had collected with the other teams who could make good use of it. Many of our team members were also spending their downtime walking around the pits, talking to other teams, looking closely at the designs, asking questions, and learning. It's always incredible to see this open exchange of ideas, and that's what First is truly all about, beyond just getting points on the board. The judges were also making their rounds through the pits today. After the initial former interview on day 1, they do these follow-up pit visits. And we had a few visits, and the team felt really good about how they presented their outreach efforts, their programming, and the engineering challenges that they'd overcome this season. Thankfully, we only had 4 matches scheduled for today, compared to those 5 hectic matches from day 2, so there's a lot more breathing room between matches. This made the team noticeably more chill, back to the practice fields for a lot of autonomous tuning and programming. Match 8, our second of the day, saw a much improved autonomous run after all that practice. We still lost this match, but seeing that auto work better was a small victory, and the confidence was starting to grow. That focus time to slow down, analyze the data, and really think about the programming logic definitely helped. Unfortunately, during the driver control period, we hit another snag. Our outtake gear slipped a tooth, and that meant that the claw couldn't quite close enough to properly grasp those game pieces. Back in the pit, with no time for a major mechanical teardown, our programmers came up with a really clever workaround. They simply added a button to the controller that would make the claw motor close just a little bit more than its usual close position to compensate for that slip. Some really amazing problem solving under that pressure. Our second last match of the competition, match 9, was exactly what the team needed. Nothing broke on the robot. That extra close button for the claw worked brilliantly. Simple fix and allowed us to manipulate specimens effectively. We still lost on points, but the robot performed as intended, consistently and reliably. And that feeling of control was huge for the team's morale. We finally had a match with no bugs and could perform consistently just like we'd done back in the Netherlands. And our confidence was back. Going into match 10, the final qualification match for us for the entire tournament, things were finally clicking. On the practice fields, our autonomous routine was hitting its marks consistently and driver controlled was looking solid. We were also paired up with a really smart and collaborative team from the USA who shared a lot of knowledge with us. For this last match, the team felt like it was their bot, the one they envisioned with all those robot gremlins finally exercised. And they absolutely delivered. The autonomous mode, 4 game pieces score. Through the driver control period, they were a scoring machine. Our best performance of the entire weekend by a long shot. And to cap it all off, in those tense final seconds, they went in for a hang, and the string didn't break. That one match made all of that struggle worthwhile. So day 3 ended on that massive high. We finished the qualification rounds, and later that evening, the alliance selections for the division finals took place. We weren't chosen to be a partner, which was expected given overall ranking. But honestly, it wasn't that heartbreaking. After the last match performance, the team had already achieved their personal victory. We celebrated with a team trip to the Houston Astros ballgame, perfect way to unwind. Day 4 of the championship is all about the final matches with the best of the best and the awards. Our team didn't win any of the major judge awards this year, and that was okay. And our good friends Litbot from Lithuania secured 3rd place for the Inspire Award in the winner. But more than anything, day 4 was a chance for our team to truly appreciate the sheer mind-blowing level of competition at the first World Championship. To give you some context of the insanity of some of these robots, our highest score all weekend was 365 points. In one of the grand final matches we watched, an alliance scored 312 points in just the first 30 seconds of the match alone. Absolutely incredible, and seeing that top tier play was really inspiring for all of the team. So that's a wrap on the first Tech Challenge World Championships for the Into the Deep season. Did we achieve the competitive results on the scoreboard that we had initially dreamed of? No. Were there moments of deep frustration? Absolutely. But the team left Houston feeling genuinely inspired and stronger engineers from the experience. Overwhelmingly, they were fired up and already looking forward to the next season. I've already overheard them excitedly talking about off-season projects, new designs, and how they can apply all those hard-won lessons from this year to come back even stronger. And that right there is the real win. It's about the growth, the problem-solving, the resilience built, and that passion ignited. I am so proud of what this team has accomplished and how far they've come. And that's the power of FIRST. If you found value in watching our team's journey, the engineering challenges they tackled, and the lessons learned along the way here at the World Championships, please consider giving this video a like. And if you want more insights into competitive robotics, program tutorials, and a deeper look into the design process, consider subscribing. I've got a lot more to share. Thanks for watching, and best of luck on your next robotics project.